This work is our last few years working on the paleochannel mapping and the paleochannel analysis in the central Gawler Craton area. It's mainly focused on the GP2 paleochannel mapping. This project, the first project focused on the mapping, and the second project, extension project, focused on the key drill hole analysis. And we use that for the sedimentary characters analysis. Today's talk about this, and the next step will move down to the south, focus on the Nardi paleochannel area for uranium or heavy minerals or the RE. So now we should understand this area, the geological contour. So from our understanding this area, we got two generations of the paleochannel, or three generations, sorry. The late Paleozoic, Mesozoic, and Cenozoic. Below that, we call this the basement. So we include that early Paleozoic as a basement. And the basement rock mostly were significant for providing some mineral source like heavy minerals or uranium. So now we can see what relationship between these channels. You see, over this area and over this area, the three sedimentary basins, the different generations overlap each other of their marginal basin. We know the paleochannel mostly just occur in the marginal basin. So we need to work out what relationship between this and between these generations. This is unconformity, just separate these sediments, and then we want to work out these sedimentary phases. And for mapping, not easy and also not complicated, but we should know what kind of method you can use. So this is very important. So our second edition, this is statewide of the paleochannel map, but for the GP2 project area, we using the new tools, for example, like a high-resolution geophysical work. So for our second edition result, we are not included in the Paleozoic paleochannel over there, because by then we didn't have the good tools. But today we know this is a paleochannel occur there. This is several examples for what kind of a method we use. This is very important for the certain area. You should use this method right, because all these methods we use based on the geological control. For example, like this area, it's Talaringa paleochannel. So you can use a landscape. The image is very beautiful. You can map the paleochannel because it's a circuit cap just occur along the channel. But this is not working in the other place, for example, like Garford paleochannel, or even down to the south of the Kingunia paleochannel. But if you go to other place, also you can use like nighttime thermal or the DEM. You know, DEM normally just showing the surface signal, and then you can trace that. Oh, here maybe paleochannel, maybe not. If you want mapping the boundary, not possible. So if you want mapping the boundary, you should using the subsurface method. So we call this a nighttime thermal. I mostly prefer to use. Reason is cheaper, effective. But problem is, you should get the right data. How to get the right data is to control the water table. For example, when the water table over there, and then you can get good enough moisture control, and then you can get good enough thermal contrast. Otherwise, you will miss that. Later one of the slides I will show you. And for getting this, for example, you have to check USGS or NASA website day by day, month by month, and year by year. You should get a good season. For example, like South Australia, we get appearance is springtime is a good time. For example, like September. But when we work on the Euclid Basin, you know that another half in the western Australia. If you go to Western Australia, you want to use the method, this is January, February. That's a good season. Otherwise, too dry and too wide. For GP2 paleochannel area, we're using the high resolution gravity. So this is a very useful work. And the last year, we did work with the 4 new Paleovalley name. And then we work out this Paleovalley mostly follow the glacial flowing. So regionally, they just flowing from this direction to this direction because by that time, Gawler Range area is an Iceland area. And then most of this Paleovalley just follow the topographic load. This is one of the very good examples of the common fund. This is from Norway. You can see this Paleovalley, this glacial Paleovalley. So compared to our place, it's a very good example just to show what this is working. And the next step, after mapping, we choose several the key drill holes, and then we analyze these drill holes. We spend a lot of time last few years and work out depositional environment or sedimentary evolution. How this Paleovalley evolve and what relationship between them. So this is one example of the cross section showing this is how this relationship between this Paleovalley. This is the Paleozoic, this is the Mesozoic, and this is the Cenozoic. So the old one, the Mesozoic and the Paleozoic, the Paleovalley just flowing the direction other way around compared to the Euclid Basin. And the Euclid Basin going this way around. So this is important when you working on the next slide. This Paleovalley we just found from Margasing. So we give the name Margasing Paleovalley, but before you can find from a literature calling this Margasing trough. The trough maybe contains older sediments, for example, like Cambrian. But Cambrian here, for us, is the best bedrock. This is another example along this Gulf of the Paleovalley. So we worked this a long time ago for the CSD work. So you can find what relationship between this Paleovalley. It's a Paleozoic and the Mesozoic and also the Cenozoic. So this Paleovalley in the certain area you can say they intersect each other, but not always. Maybe somewhere missing, maybe somewhere just going across. So this is a very important work out what relationship between this Paleovalley. So this is just a two dimension we review, but if you go to the 3D modeling, so you can see a lot of different information you can get. Now, the third step, we just want to go into how to use this information, work out what potential of this area, what kind of mineralization you can find. So in this area, we just summarize like minerals, uranium, clay minerals, gold, coal, and several important the value just in this area. Also from different layers you can find anywhere and any kind of minerals you can find, including groundwater. So this is another example in the Kingunia Paleochannel. If you can get good enough data, especially for the drilling data, you can use the 3D modeling software to work out the relationship between this valley. This is one of the cross-section in the southern part of the Kingunia Paleovalley. Even within this one section, you can find the several different potential, for example, like uranium, placer gold, and coal. And another important in this area is for the heavy minerals. In the heavy minerals, we just work out in South Australia, you can find lake deposit, transgressive deposit, regressive kind of deposit, and iron. For all of these four kind of deposits in the Euclid Basin margin, that's right, yes, they contain for all of these different types. And also for the longshore drift type, is important for forming the heavy minerals in the Euclid Basin. So this is a typical example. It's from Jason's area. This is the Jason area model. And also for the regression type here, so you can find in this area, we call this a Neogen coastal plain. It's a different story. Just going to Mesozoic. This is another exciting story. A long time ago, it's 2009, when Diatrium just working in this area. I worked with them for a long time, and then at the beginning, they are reading their report, just saying, "Oh, this is Paleozoic." So what this means, Paleozoic? This is the Eromanga Basin, Eromanga margin. So when we review these samples and their sedimentary cross-section we found in this area, this is the Archeronga Basin. So the faces is Archeronga Basin, it's Eromanga Basin. It's not. This means Mesozoic. So in that case, for all of this type deposit, it occur in the Eromanga Basin, maybe not. So we are thinking part of that, maybe the regressive type is occurring there because the faces, sedimentary faces analysis not support that. And for this longshore drift type, no, because it's evolution faces not showing that. And for this is longshore drift part in that area, maybe not, because we don't have enough information so far over that area. For regressive, yes. So compared to the Mara Basin, it's very, very similar. This is one example last year, the Peterson and Momoto just got a new discovery, just support our idea. You see, all mapping this part, the middle part, we missed. What reason? Because by that time, we're using the AEM or we're using the nighttime thermal, not showing signal over there. So we thought maybe the sediment erode away, or maybe not happen there. But later, when this year we're talking about the petrothermal for detail, so we thought, we interpreted that our nighttime thermal image data we all the time maybe not right, because the water table is pretty low. So it's dry. And we couldn't get thermal contrast over there. We couldn't get the conductivity contrast over there. And compare this area, if you want looking for the heavy minerals, maybe you can find different type of this coastal line, coastal plain in that area for Mesozoic, Cenozoic, or Paleozoic. Paleozoic, we don't think Paleozoic contains heavy minerals over that area because it's too cold. And also for uranium, maybe the paleoclimate model not support that because we need carbonation and we need some reductant information. I just give this talk in October for the uranium conference. Summary. So the best method for mapping paleochannel, nighttime thermal, is cheaper. And then the DEM for the best and the effective one, maybe plus passive seismic. So all this detailed talk you can find in the report book will coming soon. Thank you.